Okay, we have a large quantity of dust should have been left behind after the creation of the solar system. A larger dust particle comparable in size to soot and sand grain are common. They create shooting stars when they collide with the Earth's atmosphere. But very small dust particles are conspicuously absent. Astronomers believe that their very small particles have been blown out by the solar system by the sun. By comparison of the force of the dust particle determine the diameter of the small dust particle. So the question here, we need to find the diameter of the small dust particle. What is it? So, assume that the dust particle are spherical. So, the area of a sphere is 4 pi r2. Okay? And then we have the density is 2000 kilogram per meter cube. The power of radiation from the sun is 3.9 multiplied by 10^26 watt. This is the information that we have and we need to find. First thing first, we need to find the intensity that comes from the irradiation. This is the first part, and that's power divided by the area of the sun. And the area of the sun is spherical too, so it's 4 pi r2 of the sun. So the intensity will be equal to 3.9 multiplied by 10^26 watt divided by 4 pi. Where is the radius of the sun? It's 7 multiplied by 10 power of 8 square. So the intensity of radiation will be equal to 63 times 10 power of 6 watt per meter square. And then to know the pressure of the irradiation. So the intensity of the irradiation is equal to speed of light multiplied by the pressure. So the pressure will be equal to intensity of the irradiation divided by the speed of light. So the pressure is equal to 0.22 pascals. And then we can find out what is the force of the irradiation from the dust particle, and that's pressure multiplied by the area of the dust. Now, this is where we're gonna use this formula to find the force of gravity from the sun. And then let's write it down this way. The force of radiation is equal to pressure, that's 0.22 pascals multiplied by PR2 of the dust particle. So we're gonna use the force of gravity here to find the force of radiation will be equal to force of gravity. Force of radiation to find the radius of the dust. So force, let's start force of radiation is more simpler. Pascals multiplied by P R2 of the dust equal constant of gravity multiplied by the mass of the sun multiplied of the mass of the dust divided by the radius of the sun. Now here the density, just to find the mass of the dust, we have the density of the dust. So the density is equal to 2,000 kilogram per meter cube. And we know that the mass or the density is equal to mass divided by the volume. So the density is equal to mass divided by the volume of the sphere is 4 divided by 3 pi r3. This is only the part to replace to find the mass of the dust. We can use it in the force of gravity. So the mass will be equal to density multiplied by 4/3 pi r3. And this is what we're going to use in the formula up here. So let's write it down again. 0.22 pascals multiplied by pi r2 of the dust equal constant gravity, that's 6.67 multiply ten minus 11 multiply by the mass of the sun, that's 2 times 10, 30 kilogram multiply by 2000 multiply by the volume divided by the radius of the sun square. Okay, I'll write it down so we can use the mass here for the density. That's 0.22 multiplied by PR2 dust equal to, let's multiply these two together. It will give us 1.33 times 10 power of 20 multiply by 2000 multiply by 4/4 PR3 divided by the radius of the sun. How much is the radius of the sun? Radius of the sun is 7 times 10 power of 8 square. So now we can cancel out this one here and this one and this one. So now we can isolate the radius. So here, this is when we need to find this one here, the radius of the dust. So radius of the dust will be equal to 0.22 multiplied by 7 of 8 square divided by 1.33 times 10, 20 times 2000 times 4/4. Okay, so So the radius of the dust is going to be equal to 3 times 10 minus 7 meter. So the diameter of the dust is equal to 6 times 10 minus 7 meter. There is another way to do it, is that you can take the force of radiation is equal to the force of gravity. Force of radiation will be equal to power. Okay, let me put this one first. First equation, this is the second equation. So the first equation, force of radiation is going to be equal to power divided by the area of the sun divided by speed of light multiply by the area of the dust. Okay. So to come to the force of radiation, to come to this formula, we can use the intensity is equal power divided by the area of the sun, and then we can use the intensity is equal to speed of light multiplied by the pressure, and then force of radiation is equal to the pressure multiplied by the area of the dust. And if you combine all these three formulas, it will give you this formula here. And the second formula of the force of gravity is going to be equal to constant gravity equal of the mass of the sun and the mass of the dust divided by the radius square of the sun. So you can combine the 1 and the 2 So let's say power divided by 4 pi r2 of the sun divided by the speed of light multiply by the area of the dust is equal to gravity mass of the sun, mass of the dust divided by the radius of the sun square. So this is the first formula. The second formula